Hi, folks. Today's topic kind of looks like a lot of stuff, but they all kind of fit together nicely. Increasing, decreasing, relative extrema, and then odd and even functions. So odd and even functions we're going to deal with on the back. So what our goal is for today, we're trying to be able to look at a function and identify where's that function going up, where is it going down. That's what I mean by increasing and decreasing. Relative extrema, those are mins and maxes. So let's add that to this. Increasing is where the graph is going up. Decreasing is where the graph is going down. Relative extrema are mins or maxes. So let me talk a little bit about relative. Like this graph here, let's look at this first one. Does this graph have an absolute maximum? In other words, is there one point that's the highest point on the graph? Well, it's kind of tempting to say, yeah, right here, that's the highest one. That's not true. Because what do we have at the end of our graph here? We have some arrowheads. So that means that the graph goes up, 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 up forever. So there is no absolute maximum to this function. But we do have what are called relative mins or maxes. This is a relative max because relative to the points around it, it's the highest point. Relative to the points around this, this is the highest point. So if I look at this, this is relatively a low point. This is what we call a relative min. This is what we call an absolute minimum. It is the lowest point on the graph. This is an absolute min. But it's also known as a relative min. So you can have a relative min that is absolute and relative at the same time, but you can have a relative min that is also not an absolute min or max. And that's an example of a relative max. It's not an absolute. This is another relative max. So when we're talking about increasing and decreasing, we're always referring to y values. Increasing, my bad, I said that totally wrong. Increasing and decreasing are always referring to x values. It's the x values where the graph is going up. Mins and maxes are y values. I'm just going to put a y this time. X values and y values. So as I look at this picture, what is my graph doing from the beginning? So I always look at this when I talk about increasing and decreasing, I always look left to right. So from the left, my graph is going down, 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 down. My graph is decreasing. So I want to start down with decreasing. Now, when I'm talking about x values, I don't want to look at the height. I don't care about the height. The height just tells me that I'm decreasing. What I do want to talk about, though, are the x values that correspond to those points that are decreasing. So if I go way down here, what x value is this? This is negative infinity. So negative infinity, my graph is decreasing from negative infinity, all these x values, until I get to this spot right here. So what's the x value there? The x value would be negative 8. So my graph decreases from negative infinity until negative 8. Then what does it start doing? It starts to go up. It starts to increase. So now I'm going to go up to increasing from negative 8. Oh, that looks awful. From negative 8 until my graph increases, increases, increases. Now it's tempting to write 6 here. That's not right. Increasing and decreasing are always referring to x values. So when does my graph stop increasing? At the x value of negative 2. And once my graph stops increasing, what does it start doing? It starts decreasing again. So I want to go down to decreasing. And remember how we did this with domain and range. You have to write the union symbol. That's joined with, now once I stopped increasing, I started decreasing. And I decreased until I got to an x value of 0. Then we started to increase again. So I'm going to go union from 0 until 2. My graph is going up. And then from 2 until 5, my graph is going down again. And then from 5 until infinity, my graph is increasing. Now, I don't mean infinity this way. I mean infinity this way because these are referring to x values. Relative mins and maxes are referring to the actual y values. So where is one of our, coming from the left, we have a relative, this is a relative min. It's a low point. So we would say that we have a relative min of y equals negative 4 at x equals -8. So it's kind of annoying, but you got to write them both in there. And you want to write the y value first because that's the min. So I have a relative min at y equals -4 that occurs when x is -8. So I keep going, I keep going. This is that was a point, but it's not a point that's a min or a max, so I don't really care about it. This is a relative max, so I have a relative max of y equals, oh boy, I got to squeeze all this in here. I don't know if I have enough room. A relative max of y equals 6 at x equals -2. Then I have a relative min of y equals 0. Gosh, this is all messed up. I don't like these notes. Y equals 0 at x equals 0. Then I have a relative max. I have a high point of y equals 10 at x equals 2. Then I have another low point. And what's nice about this is when you have relative minima at two different places, you don't have to write it again. So I can just say we have a relative min of y equals 0 at x equals 0 and x equals 5. So that covered both of them. I'm going to have to see if I can maybe shorten this up and extend this a little bit more to give us some more room to write there. Sorry about that. And we're kind of stuck with it for the next one as well. So now that we've talked about it, let's see if you can pause here and try to do the next piece on your own. Okay, let's see how you did. So remember, increasing and decreasing, these are x's. Relative mins and maxes, these are y's. So what is my graph doing first? So from the left, my graph starts off increasing. If I go all the way to the left, where am I? I'm at -infinity. And then it increases until we get to -7.9. Now, when it comes, I should have said this the first time. You never include increasing or decreasing because those low points, those high points, those are never going to be, I mean, think about it. If you're on the top of the mountain, are you going up or are you going down? Neither yet, right? You haven't started, you finished going up and you haven't started going down yet. So that's why this is not included. You never want to include those values. So then I start to decrease. I decrease from -7.9. Decrease, that's a 0, but it's not a, we don't get, it doesn't help me increase or decrease until I get down here to -2.8. Remember, I'm only looking at x values here. Then I start to increase again, so I need to union from -2.8 until 1.9. Then I decrease again, so union from 1.9 until 5. And then we start to increase, and we increase from 5 until infinity. Now notice I'm saying infinity, not because I'm going up, but because I'm going to the right. We said increasing because it's going up. Now we're going to do any relative minima. So I start off, I have a relative max. Let me see, I've got two of each, so I'm going to separate them right now so I don't get confused. I have a relative max of y equals 8.9 at x equals -7.9. Then I have a min of y equals -3.6 at x equals -2.8. I have a max of y equals 1.8 at x equals 1.9. And then I have a min of y equals -0.8 at x equals 5. Okay, so what happens when they don't give us the picture? Well, we got to go get the picture on our own. So I'm going to go to my calc. I'm going to make a sketch, x to the third. Now, this isn't one of the functions that fit into our transformation of parent functions, so we would have to use our calculator here. Okay, so I'm trying to figure out where is my graph increasing and decreasing. So coming from the left, what is my graph doing first? It's starting to increase. It's increasing from -infinity, not because it's low, but because it's coming from the left. So I'm going to start off increasing. Now, this next thing, you should be able to write down 3 things. The next step, I'm going to be able to I want to figure out where that location is. And I should be able to say where my graph stops increasing. I should be able to say where it starts decreasing, and I should be able to do a min or a max. But I first have to find this location. The way we do that is underneath calc. You have min or max identified. So you can choose min or max, whichever one you want. I'm going to choose this to be, that's obvious. Sorry, let's go back to the graph. That's obviously a maximum, right? That's a high point. So second, calc, max. Now your calculator is going to ask you 3 questions. It's going to say the left bound, the right bound, and take a guess. So that means that I just have to get this little blinking cursor here. I've got to get it to the left side of that high point, anywhere on the left. Here works, here works, here. Notice I'm using the left and right arrows. But you can get, as long as that would be fine too. I always like to give myself a little more room. I'm definitely on the left side of that high point. So I hit enter. That sets up a little arrow. That's my boundary. Now I'm going to move to the right side. I get somewhere on the right. I hit enter. That sets up my other boundary. You can't really see it because it's on the y-axis, but there's another arrow here. And then it's going to say guess. You just move that as close as you can to where you think the high point is. Don't overthink it. Just get close and hit enter. Now, like I said, you should be able to write down 3 things. You should be able to say that my graph stops. Okay, by the way, this is the number -1. If you write -1.000002, you're going to get it wrong. That is not that point. That's your calculator making a slight mistake. -1.000002 is really -1. Just like 0.9999999 is really 1. Okay, so remember, I'm looking at x values for these and y values for these. So my graph stops increasing at -1. Well, if you stop increasing, you start decreasing. And then we also have a relative max of y equals 2 at x equals -1. See how I wrote down 3 things? I was able to say I stopped doing something, I started doing something else, and then I was able to do one of these. Okay, so now my graph is decreasing until I get to this spot. Second, calc. This is a minimum now. I'm trying to find the lowest point. Now I'm still trying to stay on the left. So there's the min. I want to move somewhere to the left of it. I'm on the left side, good enough. Now I'm going to get to the right side, enter, and then I'm going to take a guess. Okay, this 1.0000, that's really 1. So there's 3 things that I can write. I have stopped decreasing. I have started increasing, which means I need another interval. And I also have a relative min of y equals -2 at x equals 1. And then you can just finish at this point because my graph increases the rest of the way, so it goes to infinity. All right, pause. Try to do the next one on your own. This one's going to have some decimals. And then come on back. All right, so let's see how you did. 2x to the 4th minus 16x to the 3rd is 45x squared minus 52x plus 18. So what is my graph doing first? My graph is decreasing. I'm going to change my window so you guys can see this a little bit better. So I'm going to start off, my graph is decreasing. Decreasing from negative infinity. Now that's not because it's up, it's because it's left. It decreases until it gets there, so I got to figure out where that there is. So I've got a minimum. I'm on the left side, enter. I got to get to the right side, close enough, enter, then take a guess. So I should be able to write down 3 things. I stop decreasing at 1.13. I start increasing at 1.13. And I also have a relative min of y equals -3.125 at x equals 1.13. All right, then I'm starting to increase. Now I got to figure out where I stop increasing. So that's a max. Enter, left. Get on the right side, enter again, then get to the high point, take a guess. So I stop, well, what number is this? 1.9999999. That's the number Sorry if you can't see my screen very well. That's the number 1, 2, 2, 2. 1.9999 is 2. So I stop increasing at 2, and I start decreasing, which means I need a union symbol because I have another intersection or interval. 2 things I can write here. Now my third thing, that's a relative max of y equals -2 at x equals 2. Then I'm decreasing until this low point, so I'm going to go again. That's a minimum. Somewhere to the left, somewhere to the right. Take a guess. So I've got a minimum. Oh, this is another, look, this minimum is at the same minimum that I was here. I hope you can see that. That's not helping. Let's try this way. So this other -3.25, I'm just going to put and x equals 2.87. Make sure you round properly. But those both have the same y values. So I stopped decreasing at 2.87. I started increasing at 2.87 until infinity. Okay, I'm going to stop here, and I'm going to do the second part of the video, second part of notes in another video.